Give me a second. And today we'll be starting with the multivariate analysis, okay? So univariate and bivariate we have completed. In the univariate, we explored the data, and in bivariate, we try to clean the data. Now we are going to talk about the multivariate analysis. And I'm saying multivariate analysis, which means we are going to pick up the combinations of different type of columns altogether. Okay. So this combination, when we jump into the multivariate, the first thing which we perform in multivariate analysis is called as feature engineering. Okay. As per the name suggests, feature which means what? We are talking about columns, right? Now we are going to engineer some new columns on the basis of the previously present columns in the data set. Okay. Now you know that we perform cleaning in the data. While we were cleaning the columns, we were finding the redundant type of values, or you can say the similar type of values with the help of correlation, right? Here we clean the data in the observation manner. Now my data set is in the correct format. Now what I can do? First we explore the data, we clean the data. Now we are going to perform analysis on the data. And while performing the analysis, we have one thing called as feature engineering. This feature engineering means that we are going to create the column on the basis of the previously present column, which means consider you are having this loan data set, right? Say DF1. In this loan data set, you can see we have so many details related to the loan. But do we have any column where we are getting the loan to income ratio, where we are getting the calculation of EMI, right? These all things, if I declare here inside the data, that is going to create a good pattern while fitting this data into the machine learning model. Okay, so basically to make my model learn, right? How my model learns with the ample of the data set and the patterns, right? So if I'm going to declare so many patterns here in my data set, what will happen? I'm going to put this data set into the machine learning model. It is going to give me the higher accuracy because we have declared something which is going to create the good relationship between this data set or the domain of loan. Okay, so in this case, what we are going to do is we are going to engineer some new feature that will help me or model to find it accurately, the efficiency. Okay, so engineering the column means we are going to pick up some of the combinations from the previously existing column and going to create new one. Okay, why? Because this is going to help me to add more pattern to my data. Okay, and that is called as feature engineering. Now feature engineering we do with the normal commands of the pandas, also with the help of functions. Okay, so let me give you the heading first and then we'll talk about features engineering. So if you guys remember in the previous session, I have already told you, please do revise the functions so that we can do something here today. You will not go blank. Okay. So in feature engineering, we'll be first starting with the normal feature creation. Okay. Understand that feature engineering is nothing but the part of your multivariate analysis. Okay. So inside the multivariate analysis, we are having this first section called as feature engineering. Now, we are going to create one feature. Suppose I'm just teaching you how to create or give more pattern to the data. We don't know the total income, right? When I'm saying total income, if you look into this data set, we are having two columns of the income, the applicant income and the co-applicant income. Suppose I want to extract or understand the total income of applicant and co-applicant so that it will give me the good knowledge for the ratio of loan. Okay, so for that purpose, can I create one column with the merging of, or let's say the sum of these two columns, the entry of application income, applicant income feature and the feature of co-applicant income feature? So if I want to create this column, which is very basic, I'm just picking up two columns and adding them up, right? So if you guys remember, NumPy, we have already done that, creating NumPy array X and then doing 1 plus NumPy array Y giving me the answer directly. And what I told you while starting the pandas, that pandas is created on the foundation of NumPy. So the thing which we have done in NumPy, we can do the same, or we can perform the same here while creating the total income column. So I'm just doing one thing, picking up my data set DF1, going to mention the name of these two columns. This is your applicant income and this is your co-applicant income. Hello, guys, can you hear me? Okay, so this is your co-applicant income. I am pasting it down right here. Now you understand that we have DF of applicant income plus co-applicant income. If I'm going to do the sum of these two columns, it is going to create one new, right? So where to save the data of these two columns into the new column. So let's say I'm going to write or declare one new column called as total income. Now you can see how easy it is for us to create the column, right? In the DF1 data set, do you understand? We saved this data set in the variable DF1, right? So whatever changes I'm going to make here is going to happen in the DF1. So I'm going to run this one and let me show you how my DF1 data set is looking like. You can see it is your whole data set. If you go by the end, you will see there is a column called as total income column. So yes, we are engineering the feature. Now it is very easy for us to do that. We are going to pick up the entries of the column later. As of now, we are just picking the column names. Okay. Like that, you can create so many different type of columns just to give pattern to your data. And sometimes what happens when your client gives you a data, going to give you the data set, they mention what to engineer and what not to, which means whenever you get the knowledge of domain, what to engineer from the data set, you will understand this by being around the data set itself. Okay. Yes, giving you a minute. If you have any sort of question, you can ask me right now. Is this okay? Okay, let's move forward and let's talk about loan to income ratio. Okay. So when I'm saying loan to income ratio, which means what? Loan to income ratio is going to help me to tell that, let's say we are having a total income present in the data set, and I want to know that how much capping of loan I can grant without any extra permission to the consumer, right? Let's say you are earning 20 lakh per annum. Now, if you are going to ask the bank for the loan of 1 lakh, which is going to be very minimal amount related to your salary. So in that case, bank is not going to cross check or cross verify or take in charge of your information. Okay. In such cases, they will easily grant a loan. So once your applicant income is huge, or let's say once your income is very huge, granting loan for very small amount becomes easy, right? And very, let's say, obvious. So in that case, we are going to judge this with the help of total income, that what percentage of the total income I can grant to the people easily. Okay, let's say if somebody is coming with the income 40,000, if he or she might be asking for the loan of 1,000 or 1,500 rupees, I'm going to easily grant because my loan to income ratio says that which percent of my income I can grant loan off to the consumer very easily. Okay, so this is what your loan to income ratio is. That we are going, this is ratio, right? Ratio means what? We are going to divide, or let's say we are going to perform division between two columns. Which two columns? Your loan amount and your total income. That is what going to tell me, right? Loan to income ratio. So I'm going to write DF1 of loan amount. Putting one slash here, DF1 of total income. Saving that in the new column of DF1 called as LTI, abbreviation for loan to income ratio. Okay, I'm running this. Now checking my DF1 data set. Going by the end of the data, we are having LTI. But right now, guys can see that it is not in the percentage format, right? So for converting this into the percentage format, I am going to multiply this with 100. So it is going to give me the percentage. Okay. Now you can see we are having the LTI in the percentage format. Now this LTI is telling me that overall applicant, let's say overall income, or let's say total income, of what percentage of total income I can easily grant the loan of, right? So let's say total income is 5849. I can grant the loan to that person at least 2% of 5849 very easily. That is what your LTI is saying. Okay. Giving you a minute to jot it down, and if you have any sort of question in this, you can ask me. Yes, do we have any question? Yes, guys, do we have any questions? Shall we move forward? Hello, am I audible? Okay, yeah, take your time, and we are going to close the call as 9:30 today. Okay, so no breaks in between.
Hi, am I audible?
Yeah.
I have one question.
Yes.
Talking about this data set, it is mostly readable because all the figures and all the features are well defined. But when it comes to different projects, the data sets mostly received from bank data. They are actually encoded, and most of the time we do not have any idea what features they are talking about due to data privacy issue. they mentioned that all of those things are actually imported. So I think that reduces the scope for feature engineering. So how to tackle that?
Okay. So whenever you're going to receive the data like this, where it is encrypted or encoded, there is always one thing called as UTF code. Okay. So whenever data comes like in that format, we always have UTF code to encode it. Now you are getting the data in this format, maybe, let's say in a table or tabular format. The scope of feature engineering says that suppose if I created the LTI, which is giving me loan to income ratio. Now I am dealing here with the total income every time. So the use of applicant and co-applicant income is not even there, does not exist. So now what we can do is we can either keep the column or delete it. So when we are engineering the feature, we are also trying to control the redundancy in the data set. If I'm finding that something, do you understand if I'm going to check the feature engineering or let's say the correlation of these three, they're going to come very near because I am creating the column based on these two. So whenever we create feature, the chances that redundancy is going to get created, we also delete feature one by one, which is of no use. Okay. So whenever you deal with the feature engineering, of course, it is going to enhance the storage, but at the same time, you can remove most of the columns which are not in use after the pattern making. We are just defining the pattern. These are very distributed kind of data, right? I'm going to create the pattern. See, this is going to help me to find the ratio. On the basis of the ratio, I'm granting the loan. So my machine will understand in that sense. I can remove those two features now because I don't find any sort of help in that. So that's how we tackle it.
Okay, I also have one more question. May I ask?
Yeah, sure.
So there was a case study I was provided by the client, and I worked on that. I did some feature engineering and created 3 new features, which was pretty informative when I was actually doing bivariate analysis. But later on, when I built the model, it was not performing well. I mean, the training accuracy was not so good. So I did PCA, and PCA resulted into something which suggested that my features that I created are of no use to it because the other features helped in predicting the data. So the client actually asked me a question on that how did that feature engineering help you? Because now when you have implemented PCA, that suggests that all those things are not helping you in predicting the target features. So how to answer those questions?
So that's what I told you, right? When they ask you things like that, you have to tell them that yes, I am enhancing my data. On the other hand, I am removing the redundancy. What PCA told you that you are having the analysis with the same dimension here, right? Which means some of your features are giving the same type of answer. So you don't need these features. So while you do feature engineering, you need to keep that thing in mind that some of the columns are not going to get used in near future. Now they are useless. I have to delete them as well. Okay. So this is the major mistake which people does. They create feature, but they are not understanding the point that it might be creating the part of redundancy in your data set, right? So if I'm enhancing the data, I also have to remove the basic one. Okay.
Okay. Thank you.
No problem. Anybody else? Okay, chalo. Let's move. Okay, guys, because this is very very basic type of feature engineering we are performing. Now we are going to perform engineering on the basis of your entries or let's say observation. Okay. So I'm not saying to think about the data set every time in this manner. That is going to be completely your mind. What type of patterns you want to create. Okay. How you think that machine is going to understand a bit differently than before just because of this pattern. Okay. So when you learn machine learning, you will understand this combination. So I'm not putting that much effort in your brain right now. Just understand this is something which is going to be done by you only, according to your understanding of the domain and according to your understanding of the data. Okay. Come back here. Now, let's say if I ask you this question that, okay, we are not done with the loan to income ratio analysis. Let me show you one more thing. Now, if I am going to describe that LTI column, right, which the one which we recently created. So if I'm going to describe it, you guys understand that it is going to give me the statistical view of that column. Yes, it is giving. Wait a minute. What it is saying. Key error. Let me run this cell. Maybe I need to run the cells again. A minute. Okay. Now you can see now since I'm describing it, it is telling me yes, I do have 614 count, no problem, no null values. Now it is giving me something called as mean, right? So can I say that 2% or let's say 2.38% of the applicant income I can grant loan of very easily? Let's say if 615th entry comes in near future asking for the loan, and the income of that person is somewhere around 12 lakh rupees, and he is asking the loan of maybe 20 or 30,000. So in that case, I'm going to calculate 2.38% of the income. And if it is falling under that category, I can easily grant the loan. So this average is talking about that average. That whenever some new consumer come on the basis of this analysis, you can grant the loan or not. Okay. Now you can see there is one thing, guys, look into this very carefully. Your LTI, the mean and the median, are they near about same? 2.38 and 2.41, which means my data is standard normally distributed for LTI, loan to income ratio, collectively. Okay. So it is not even giving me the biased judgment. Okay. It is giving me the correct judgment of the data. So I can stick to this point that 2.38% is the, let's say, percentage for which I can grant the loan of the total income. Okay. Maximum you can go till 8.27%. Minimum you can give 0.25, and on an average you can take 2.38%. Okay. So if let's say if customer has all the green flags, he paid the loan, previous loan on time, applicant income is very good, property area is good, and then everything is falling in the correct place, we can think of even granting 8.27% of its applicant income. Okay. So it is going in that sense. Okay. Now, there is a time we are going to write functions on the data set. Okay. So I am going to create the function where I am just, this is just an example. Okay. I'm not asking you to create functions like this. I'm just giving you some of the functions for your understanding that how you can create it actually. Okay. So this function says that, or let's say this feature engineering part says that we have to create a new feature by binning them into the income group. Okay. Now there is a term called as binning. Binning means we are going to create the cappings of the data. Let's say 5,000 to 10,000, easily grant the loan. 3,000 to 5,000, what we are doing? We are creating a bin, right? We are having a range. So collecting such type of data coming within that desired range, we call that as binning. Okay. So this binning says that we have to divide. Yes, we have to divide on the basis of their incomes. Let's say those who are having the total income as less than, let's say, 5,000. Yeah, total income less than 5,000. I'm going to say that it is low income category. Now, if somebody's total income is between, let's say, 5,000, total income is greater than 5,000 and total income is less than 10,000. So we call them as average income group. And the third one, if somebody exceed 10,000 limit, I'm going to say that they are high income group. Okay. So we have to now create the analysis on the basis of this. So if you go back, you will see that there is one column which is taking the participation. Which one? Total income. Now inside this total income column, I have to do the analysis, which means I have to pick each one of the entries of total income. Okay. And we have to write the feature engineering on the basis of that. We have to create one feature on the basis of this. Previously, we were just dealing with the columns. Right now, we are dealing with the data present inside the column. And I'm going to bend them up. So whenever the condition like this arises, when you are not dealing with directly the column, but the data present inside that column, we take the help of functions. Okay. Usually we use user-defined function so that whenever the pattern gets repeated, I can use that same function again. Okay. But some of the places you will see lambda as well. Okay. So we will see both. How to write user-defined function on the data and how to write lambda function on the data. So coming back to the point, this is your total income column, right? Here I am going to simply write one function on the basis of this condition. Okay. So since I'm going to write the function, this is going to be the normal one, very normal one, basic one. So let me ask you guys to write the function for this. Don't pick the columns or such, just pick the variable as total income and write a function for it. Chalo, let's do that. So I'm defining one function, let's say DEF income group. Okay, wait a minute. Yeah. DEF, let's say income is the name of my function. Now I'm passing one parameter, let's say VAR. Okay. Now I'm checking the condition if VAR is less than 5,000. I'm going to return low income group. Okay. LF variable is greater than 5,000 and variable is less than 10,000, then I'm going to return mid income group. Now, in the else part, if it is greater than 10,000, then I'm going to return high income group. Okay, this is your normal function. That is how you're going to write it. Suppose if you want to check if it is working properly or not, I'm just simply writing income as 5,000, let's say here mention. Okay, done this, you can see it is giving me mid income group, which means my function is running perfectly fine. Now I have to use the same function for the above data set. Okay, now you need to understand one thing, that we have to write the function like this, but the calling of function is going to be different. Okay, here VAR, which means we are accepting one argument. So instead of writing income of the number, can I simply write DF1 of, let's say, total income dot apply. So basically what is this? This dot apply is going to apply your function on that particular column or the whole data set. Now here the calling of function is going to be different from as that of we learned in the basic Python, right? There we simply write the name of the function and pass on the parameter or argument. But here it is not the case. You have to mention in which you are going to apply your function. Now you are applying your function, you need to mention the name of your function as well, right? So what is the name of my function? Income. Simple. So this is going to run your function on the total income column. Okay. Now it's very easy. What we have to do, we have to save these changes in somewhere else, right? Because we have to create column, it is going to return low income group, mid income group and high income group. So I'm just creating one column, let's say binning, and here equals to, simply running this. Okay, here it should be open and close parenthesis. What happened? Total income. INCOME. Okay. Okay, so you can see we are saving this data in the binning column. We are applying the function in the total column. Which function? Income function. So here when you write simply dot apply, this total income will go inside the variable, right? What is going to get substituted? Whatever you are mentioning here in this section is going to become the parameter of your data set, argument of your function. Okay, so this is going to be the argument of your function. Everywhere variable is written, this is going to get substituted there, and it is going to return low income group, mid income group, high income group, where? In this binning column. So if I'm going to run this and going to check the data set DF1, here you can see it is giving me mid income group. So total income is 5,849. That's why it is giving me mid income group. Now, if something is less than 5,000, low income group. Okay, so that's how we are creating the columns with the help of function. Now, let's say you have done binning. There is one more type of binning which you guys need to do. You have to create a column for stability and instability. Stability and instability. How come? Here is your condition. It says that whenever somebody is married and education is graduate and not self-employed, we are going to call them stable, else unstable. Now you guys understand that previously we were just picking the single column. Okay. Now here we are going to pick the multiple columns. Your married column, your education and your self-employed column. All three are getting involved. So you need to understand one thing. Here we are going to apply the function on whole data set. Okay. So whatever you are choosing here as the parameter, you can pick that variable as the parameter and you can simply write with the bracket loan amount. Getting it? If we are going to pass DF1 only here, you can mention the columns, right? So instead of mentioning the column, you can simply write variable and within the bracket column. Simple, no change. Write the function as it is. Instead of this variable, write the column name including with the variable. That's it. No difference. Getting the point? Just because most of the columns are taking participation here. Write the function except only one parameter, okay? And with that parameter, you can create the combination of columns. See, now we are taking the multiple columns, right? We are taking the data of multiple columns. So we are going to write one function for this. Let's say define The name of function is stable. I am choosing one parameter inside it. Now, can I simply write if VAR of married and VAR of education? We are going to write conditions, don't worry. I'm just copying the name of the columns altogether. VAR of self-employed. Okay. Married is equals to yes. Education is equals to graduate. And variable of self-employed is equals to no. Then return stable. Else return unstable. Okay, so this is your condition. If variable of married, education and self-employed, we mentioned all of these things. Now we are going to apply the function on whole data set. So simply writing df1 dot apply. What function we have to apply? Stable. Simple. And where we have to store the entry? In one new column, let's say stability. Running this. Wait a minute. Okay, one more thing. If whenever we apply the function on whole data set, we have to mention the axis. Here, axis is equals to 0 is for rows and axis is equals to 1 is for columns. This here, it is different from that of your numpy. Okay. So, my bad. So, we are applying the df1 data set, or let's say we are applying the function on df1 data set. Now, we have to also mention that we are going to apply this function across the rows or across the columns. So what I told you, axis is equals to 0 for rows here and axis is equals to 1 for columns here. So we are applying across the columns, right? That's why I'm mentioning axis is equals to 1. So whenever you are not running the function on single column, but on the full data set, you have to mention across which axis you are going. Either the row axis, which is going to be 0, or either your column axis, which is going to be a 1. Now, if I'm going to run this, again, let's check. Okay, we have to enclose them inside the parenthesis because we are using the bitwise operator. If you guys remember, when we were talking about the operators, I told you one thing. That bitwise is going to work same as that of your logical, but somewhere only bitwise works, not the logical. If you are going to remove the ampersand here, from ampersand here and going to write A and D logical operator other than bitwise, it is not going to run. It is going to give you error. So, suppose if I'm going to check my df1 data set for the stability purpose of pinning, you can see. Okay, so you can see unstable. When it is unstable, when we are having self-employed as no, okay, graduate, yes, and married is no. One condition is false. That's why it is showing this unstable here. Getting it? So whenever you are applying this on your whole data set, you have to mention the axis. Also, here you have to mention the bitwise operator. Now, because we are checking the thing observations one by one, right? Either we are applying the function on whole column or let's say whole data set, but it is going to go row by row. So for that purpose, we have to choose bitwise AND so that it can consider every observation as bit and perform its activity. Okay, here your logical AND will not work. Now the another characteristics inside the multivariate analysis is filtering of the data. Okay. You might know that in Excel we do have filtering option for every column, right? That is how we are going to filter data here with the help of lock and iLock. Let's say lock and iLock. Okay. Now most of you people will say that we can perform filtering without lock and iLock as well. Yes, but it is going to consume the data more as compared to that of lock and index locking. This says that whatever you are extracting is the part or let's say clone of your pre-existing data, not going to consume some extra space in the memory. But since if you are not using this lock and iLock while filtering the data out, yes, we have a way for that. So it consumes extra space of memory just to keep the output or the copy of the data. Okay, so lock and iLock is very useful while handling the huge chunk of data. Okay, because it helps you in the storage management. Now we are not understanding the storage, why it is very important, why we always talk from storage point of view, because the data which you guys are going to deal are going to come very huge in nature. Okay, and to import that data, it is going to consume your RAM. So we have to at a time think about what all we are choosing, what all functions we are writing. Is it going to create redundancy in my data set, which is going to consume extra space? Because what will happen? Your system will go slow. Okay. Even the cloud virtual machines are not that capable sometimes of, let's say, tolerating that huge amount of data. They also go slow. So we have to maintain the memory while writing the programs. Okay. That is very important thing. So lock and iLock is something which will help us to save the memory. At the same time, it will help us to filter the data out as well. Now, when I'm talking about filtering the data out, you can see I'm talking about lock. Lock is nothing but it is going to help you to filter your data out on the basis of column. Okay. Lock completely works on the column name, which means your column should have any name while dealing with the lock so that you can filter that data out. Okay. Now here in this condition, suppose if I ask you to fetch the data of all the graduate people, what you can do? You can take the simply help of lock. Simply you can write df1 dot lock. Inside that, within the square bracket, you can mention the name of your column. What is the name of my column? df1 education. Okay. If I'm going to pick this one up and mention the condition that it should be graduate. Here I'm telling you your logical and will not work. Here bitwise and 100% going to work. Okay. Let me run this. Right now we are having only one condition to filter the data out. Running this. You can see it is giving me somewhat 480 rows with all the data of graduate people. So what we have done, we filtered the graduate data out. Here you can do the same thing in the Excel by just right clicking on the column. It gives you the option of filtering the data out. But here we have to take the help of lock for filtering the data. Lock only works with the column. Understand that. iLock works with both rows and columns. But here lock only works with the column. Right now we are having only one condition to filter the data out. Later we will see how we can give multiple conditions to fetch the data. Okay? Giving you a minute. Your indexing, your slicing should be top notch for extracting or slicing the data up. Okay? Because it is very frequent activity which we perform. I want a table of stability similar way. Yeah, you can change the name of the column here. Change df1 of stable, or let's say what is the column name? Stability, I guess, right? Yeah, stability is equals to stable. Simple. The same way with the help of lock only. Just change the name of your column here and change the condition here. And guys, you can save this transacted data as well, okay, where you can either save this in some variable x, that is again going to become one, let's say, view of this data, okay. Whenever you write x, it is going to give you the copy of data. Just because it is useful to you, then only you are going to do such thing. If it is not useful, keep it as it is. Yes, do we have any question? Yes, no, maybe. Suppose now you want to extract the data on the basis of two conditions. Okay, let's say the gender should be female and the education should be graduate. Okay, so in that sense, you can simply write df1 dot log. Inside the log, you can mention the name of the column, but that should be log. Always use square brackets. Okay, remember that. We have education here, which is equals to graduate. Now here you have to enclose this inside the bitwise AND, because here logical AND won't work. Okay, I will show you this thing. Let's say df1 of married is equals to yes, and we are enclosing this inside the bracket, writing the logical AND. Okay, now I'm running this. You can see it raises value error. Okay, so that case you have to use bitwise AND. Okay, now you can see it is working properly. Okay, it is extracting the data for you for the gender, or let's say married is yes. Sorry, we changed the filter. We said married is equals to yes and education is gender. So it is, education is graduate, and you can see we are extracting the values of those two columns. Okay, married is all yes, education is all graduate, and we are having 309 observation of that. Okay, log. And right now you can see, guys, we are using log and we are giving different conditions. On the basis of those conditions, we are filtering the data out, right? Easy job. You can give the conditions like this. You can use bitwise and you can use bitwise, or you can use bitwise not as well. Okay, now this is log. As I told you, it only works with the name. So we only have column names. That's why it is like this. Now, ilog is slicing your data, right? If you guys remember, previously we were slicing the numpy, right? Array. Here we are going to perform the same thing with the data set. Now suppose you want to slice the data up. You want some of the rows and only some of the columns, not full data set. So in that case, we can take the help of ilog. First of all, we need to understand iLoc only works with the index of your data. Index means you should also follow the indexing across the columns as well. But we don't know the index positions of the column, right? Because we are identifying the columns by their name only. So how to identify the index position of the columns along with this declaration? Simply, this is the way we studied in the NumPy array. We are having the same set of indexing in the column side, which we are having in the row side. Getting it? Indexing maybe, let's say, if I'm going to print this data, df1, always starts with 0 index position for the observation. Going to happen same for the column side, starts with 0, go in the +1 manner till the right. But right now you can see the columns are countable in nature. What if we are having 40 or 45 columns? Then how are you going to identify the index position of each column? Right? You can't just manually sit and count the index position of some X column and Y column. Can't take that much effort. So for that purpose, we can simply do this practice of writing the normal for loop. Let's say for in, I'm going to write df1. Okay, dot columns. What is dot columns? If I'm going to show you that how df1 dot columns print, it is going to print all the columns present inside the df1. You can see, and it is getting printed inside a list as well. So since it is getting printed inside the list, can we simply run the for loop over it? Of course we can. So I'm just simply writing for I in df1 print I. It is giving me the columns. It is not giving me the index position of the column. What do you guys think? What changes needs to get done here to print the column name along with its index position? Any idea? Any suggestions? What do you guys think? What changes should we do in this for loop so that it could print, so that it can print the index position along with the name of the columns? Have you learned something like this before? Kya? Use your brain, memory. If you guys remember anything which we have covered that helps us to do this thing? No. Some built-in function. There is some built-in function which helps us to print the name along with its index position. No idea? No, not index. Do you guys remember something called as enumerate? What is enumerate, guys? This is the use of that enumerate. Okay, what it is doing, it is picking up all the columns and it is printing those columns along with its index position. We know the index position of the observation, but that was not the same for the columns. So what we have done, simply written one for loop. Columns are always going to be finite in nature, right? It is not going to be 50,000, 60,000. No, we know that. It is hardly going to cross maybe 150. So that many number of times we can run the for loop. It is going to run within blink of eyes. So we are just running the for loop. We are extracting the column name along with its index position. Okay. Now, since we know the index position of the columns, we can simply perform iLoc. How we are going to perform iLoc? I am writing df dot iLoc. Inside that, I am going to mention the index positions or slicing. Okay, so let's say I want to slice the rows 150 to 200. Now columns, I want 5 till 10. Simple. Slicing for the rows, slicing for the columns. We have already done that, nothing new. Running this, you can see that it is giving me the observation 150 to 200, and the index position, you can look that 5 to 10. We are having self-employed, applicant income, co-applicant, loan amount, and till the credit history. Okay, so that is how you can slice the chunk of the data.